Good evening, students. Am I audible?
Yes, sir. Good
Yeah,
evening.
and my screen is visible to you?
Not visible.
Not okay. Just hold for a second. Now it's visible.
Yes, sir.
Okay, my dear students. So today we are going to start with the new subject that is called DBMS, Database Management System. Right? Again, an important subject. You can get almost 8 marks problem from here, and the problems are very straightforward. So we are going to cover some of the basic important concepts related to the database management systems. So let's start with one by one. So first one is, can you just tell me what is database? What is database?
Collection
No
of
need to write
data.
anything. Yeah, no need to write anything. I'll just share this PDF with you. Okay. So can you just tell me what's the database? Yes, pardon.
Collection of data.
Yeah, and the collection of data. That is absolutely true. But can you just tell me it's the collection of only random data or some data which are logically related?
Some logical data.
Yeah,
Logical.
yeah, some interrelated data. Okay. Always keep in mind it's a interrelated data, not the random data. Okay. Or we can say logically related data also. Fine. Great. Now, you know that the database is collection of some related data. Like suppose that if you want to make a database of university, then you just consider the elements which are belongs to that university, like the employees, the library data, the sports data, sports activity data, the hostel data, the staff data. Like, okay, fine. Now, can you just tell me what is database management system? What is that? Can you just tell me? We are using a term called system. System means what? It's a software or hardware. So it's a software, okay? And what is software? Set of program. And what is the main purpose of this software, which is used to manage what it is used to? What do you mean by manage? Manage means insert. Manage means delete. Manage means update. Okay. And one word is manage. Then access the database. Okay. So what is database management system? It is a software or set of instructions which is used to manage and to access the database. And that software name is called database management systems. Are you getting my point?
Yes.
Fine. Suppose that you want to create a database. Okay. You want to create a database. So in database, mainly we have different type of database. One is called, the famous one is called relational, which is in the course database management system. What is this? So if I talk about relational database management system, in this the database or the data is stored in DB is stored in the form of table. Fine. Okay. Now suppose that this is my table. Okay. Now my table contains, suppose that I just want to make a table of student. Now the basic feature of student is its ID, its name, its branch. Fine. And some of the data related to student is, suppose that student having the SID S1, S2, S3. Their name are just like ABC, and their branch are CS, mechanical, or I can say again IT. Fine. Now, can you just tell me what these are? SID, SNAME, and S branch are. What formally I can say these are what? These are attribute. Okay, attribute of my table of table student. We can also call it as field, or we can call it as column. Yes, is there any doubt? Fine. And these three are called row, we can say record, or we can say tuple. Are you getting my point? So SID, SNAME, S branch are the attribute fields or column. S1 ACS, S2 BME, S3 CIT is called row, record, or tuple. Now I just want to talk about some of the basic terminology related to this my table. Can you just tell me what do you mean by cardinality? Any idea? What do you mean by cardinality? What is the cardinality of the table student? Am I audible?
Yes, sir, audible.
Can you just tell me what's the cardinality of my the table
I
student?
think three, S1, S2, S3. Three, sir.
You are talking about the row or you are talking about the column?
Attribute.
You are talking about attribute means SID, SNAME, and S branch, right?
हाँ जी.
But
Yes,
that
sir.
is wrong. So cardinality means number of records. In our case, it is three. Which one? First record is S1 ACS, S2 BME, S3 CIT, right? Can you just tell me the second terminology that is arity, or we can call it as domain? What is that? That is called the number of attribute in my table. That is three. Are you getting my point?
Yes,
Any
sir. Yes,
doubt?
sir.
Fine. Now, my dear students, the point is whenever we talk about things related to a table, we have a scientist like there is a scientist called Code, and he suggested something. He says that we can call it as its code rule. It says that no two record with same data. No two record with same data. That is, every tuple or every record should be differentiate from other tuple. Fine. So can you just tell me why code says like this? It says that the every record of my table has to be unique. And record means the complete record. It's not like only one attribute. That means there must be at least there must be at least one attribute whose value is different between these two records. Are you getting my point? What I'm trying to say? मैं ये कह रहा हूं कि टेबल में मान लो ये दो रिकॉर्ड है, तो ऐसे हर एक दो रिकॉर्ड में एक ऐसा एट्रीब्यूट जरूर होना चाहिए जिसकी वैल्यू अलग हो. दैट्स व्हाई आई कैन से these two records are distinct, or I can differentiate these two records. Are you getting my point? But the point is now why code gives me the rule. ये rule क्यों दिया है उसने? Any idea? Suppose that two records are same in my table, and then what's the problem?
avoid confusion to fetch easily.
To fetch.
To fetch
What's the
easily
pro?
based on the
No, no. To fetch. Like, okay, I need to fetch the record. That's fine. I'll just fetch. What's the problem while fetching? Any idea? No. See, my dear students, if two records are same, then it will take more time. Or I can say, suppose that your database contain 1 lakh number of records. The first record and the last record are same. If you want to fetch, you have to fetch both the records. First of all, it means even though you get the record which you want at the first place, but again you have to traverse the whole database. One thing. The second problem is suppose that two record are same, the first one and the last one, and you want to say that please update their SID from S1 to S, suppose 100, suppose SID from 1 to 1 lakh. Okay, so what you have to do, again you have to search the whole database, where S1 has is there, you have to update that one. If you are just updating some of the records having the SID S1 from the S1 to S1 lakh, but not all, then it your database is inconsistent. Are you getting my point? Again, if you want to delete one record which is present multiple times, then again you have to search all the copies and then you need to delete it. It will take more time. That's why what code says, it says that no two record with the same data. That means every tuple should be differentiated from every other tuples. Are you getting my point?
got it.
Fine. That's why to do the task, we are using a tool that is called key. That is called key. Now we have different keys. The first one is candidate key. Next one is called primary key. Next is called simple key, composite key. Next is foreign key. Next is alternate key. So we have some keys, or one is super key. So we will talk about these keys. Let's start with the tool that is called key. So first of all, we need to learn what do we mean by a key. It is a tool, or I can say it is the minimal set of attribute. So my dear students, I am talking about minimal. I am not writing here minimum. Keep in mind. But even though in the some of the government exam also they just said minimum, but actual word is minimal. Minimal set of attribute used to differentiate tuple of relation or record of relation. Fine. So it is the minimal set of attribute, my dear students. Now this is my table: SID, S name, S branch. My data is like this: S1, S2, S3, S4. Name is A, B, C, and D, and the branch is CS, IT, CS, or I can say MA. Better to say again, the name is A. Can you just tell me which is the best attribute or set of attribute which gives you, or by with the help of those attributes you can differentiate the tuple of relation? Can I say SID? because if you call S2, then this person gives you the like give you the response. If you just say S4, only this person will give you the response, yes or no. But suppose that you call the name A, then two people, one with the ID S1, one with the ID S4 give you the answer. If you just call CS branch, then one with the person S1, ID S1 with the S3. So with the help of branch or with the help of S name, you cannot differentiate each and every record of my relation. Yes or no? In that case, I can say SID is my key. Can I say
Sure.
yes or no?
Yes, sir.
Yes, yes.
Fine. Now the other case may be like, sir, what if now, my dear students, if you call just SID, fine. If you just call SID, like if you call S1, then two students will respond to you, one with the name A, one with the name B. So only S1 or SID is not the right thing, or we cannot consider SID as a key, right? If you just call S name and you just call A, or you just call B, two student with the ID S2 or S1 will reply you fine. Again, this is not the right answer. And if you just say CS, so the number of students are S1, S2, S3, and again S1. Again, this is not the appropriate way. Can I say in this case, SID, I have to call SID with their name also to get the unique answer. So you can say S1 with A. Then this student's reply. If you just say S2 with D, only this student replied. Yes or no? Always you get the unique answer. Can I say? So in this case, my key is what? It's SID with S name. Are you getting my point? Yes or no?
Yes,
Yes,
sir.
sir. Yes, sir.
I am waiting for your reply. Keep in mind.
Okay, sir.
Great. Now, my dear students, again I'll just take one more example so that we will more clear with our definition the word minimal. Suppose that this is the case. S1, S2, S3. Name is A, B, C. Branch is CS, CS, IT. Suppose. Can you say, can I say SID is my key? Yes or no? Whenever you call any S1, S2, or S3, you will only get the unique answer. In this case, if your table contains this type of data. Yes or no?
Yes, sir.
If
Yes,
you
sir.
just call the name, if each name is unique, then again you will get the unique answer. Yes or no?
Yes, sir.
Suppose that you just call name with their ID. You just call, hey, S1A, are you present or not? He respond you, yes, sir. You just say S2B, are you present or not? You always get the unique answer, na?
Yes, sir.
But it is not a key. Why? Because it is not minimal. Minimal means what? Minimal means from if you say this set is minimal, it means from here now you cannot delete anything. You cannot remove anything. Minimal means in itself it is minimal. You cannot now remove it. The maximal means it is the maximal one. You cannot add it more. If you just remove something, then their property violates. If you add something, their property violate. Are you getting my point?
Yes, sir.
Yes. Fine. It means that's why it's the minimal set of attribute. It's not the random set of attribute. The set of attributes should be minimal. Minimal means you cannot now remove something from there. Okay. Now suppose that if you say SID and SNAME is your key. Let's suppose you are saying that SID with SNAME you can differentiate each and every record. Suppose that you just delete SNAME. Then again with the help of SID also you can do the same task whichever you are done with the SID with SNAME. It means previous one was the contains some extra attribute. Yes or no? It means in minimal there is no extra attribute. Are you getting my point? That's why it's not a key, whereas SID is the key, SNAME is a key. So I can say for this table, the important point comes into the mind. That means more than one key. Now I am talking about key. Key means candidate key. Key means candidate key, my dear students. By default, key means candidate key. It means more than one key is possible for a table. Yes or no?
Yes, sir.
Fine. That's the key point, my dear students, which is very important for your exam. Is candidate key or key is more than what key is possible for a relation? Yes. Can I say all the key are minimal in nature?
No.
Because it's a key and key by default means minimal. What is the definition of key? Minimal set of attribute. That's why whatever the key is, suppose that your lesson contains some keys. Keys are one with only alpha 1 attribute, one is alpha 2, beta 1, one is alpha 3, beta 2, gamma 1. Are you getting my point? If you are saying that these you have a relation with the three candidate key or three key, it is minimal in itself. This one is minimal in itself, and this one is minimal in itself. I'm not talking about minimum. Minimum one is this one only. But each and every set is minimal in nature. Keep in mind. Are you getting my point? That's why it is key, na? If it's not minimal, what's how I can pronounce it as a key? Are you getting my point?
Yes, sir.
And always keep in mind the two important points that the first one is it is a key. That is key means minimal set of attribute which is used to differentiate each and every record of my relation. The default key means it's a candidate key. More than one candidate key is also possible for a lesson. Can I say more than one attribute will make a candidate key? Or key is always a single attribute?
More than one attribute also possible.
Yeah, it means one next important point is key may consist with more than one attribute. Is it right? So always keep in mind the second point also, the next point also, not the second point exactly. Fine, my dear students. Now let's talk about primary key. What is primary key? See, we know that more than one candidate key. Right now, I'm taking writing candidate key as CK. More than one candidate key is possible for a list. Yes or no? Now, if I select a particular key or a candidate key, and then in future I can just work with that particular set of attribute or set of minimal set of attribute, then I can say this candidate key is the primary key. So what is primary key? It is one of the candidate. But we know that we have more than one candidate key. Suppose that alpha 1 is my one candidate key, alpha 2, beta 1 is my next candidate key, alpha 3, beta 2, and gamma 1 is my one candidate key. Suppose that I am just considering alpha 1 as my primary key. Fine. Then what is alternate key? What is alternate key? Alternate keys are alpha 2, beta 1. The remaining candidate keys are called other than, I can say the better word is to say other than primary key. All remaining candidate key are alternate key. Yes or no? Yes or no?
Yes, sir.
Fine. Very good. Now, I want to give you one problem. Which of the options may be considered as set of candidate key? A1, alpha 1, alpha 2, beta 1, alpha 3, beta 1, and gamma 2, alpha 2, beta 1, gamma 3. Is it a possible set of candidate key for a relation R?
Yes, sir.
I think only one student replied. What about others? I think we have right now 17 students. So I am waiting for the 17 answers, or at least 16. Then only I can proceed, okay?
Sir, it's not primary key because if you see the last key, that is alpha to beta 1 and gamma 3, that can be divided into alpha to beta 1 and gamma 3, means where alpha to beta 3 is again a candidate key.
Okay, to answer, what about others? Okay, I am waiting for your answers, okay? And you can wait for my continuations, okay? So I think this is a situation called deadlock. In operating system, we will discuss. Hopefully, you don't want the deadlock. And if still you want deadlock, then you can leave now only.
Sorry, sir, for not replying, but actually, I do know what is candidate key and what are the all the primary keys, but I don't know this like alpha and alpha 2, beta 1, like what are these?
These are the keys, na? This is a candidate key, this is a candidate key, this is a candidate key, this is a candidate key. Is it possible this type of set is possible?
Like you mean to say all the keys are the candidates keys?
Yeah, I'm saying that I have a set.
Huh.
Can I say, and oh, I'm just considering this is a key, this is a key, this is a key, this is a key. Is it possible that all these are candidate key for my table?
Yes, sir, this is possible because all the keys are candidates keys, and there is only one key which is a primary key. But like
I'm
if
not talking about primary key right now. I am just talking about the
it is
candidate key.
possible, sir.
Okay. What about others? See, my dear students, the word candidate key means minimal set of attribute. Suppose that you are saying this is the minimal, but in that case, this is not the minimal, na? Because same thing is repeating here, alpha to beta 1. And from the, if you are saying that this is the key, means indirectly you are saying that this is the minimal one. If this is the minimal one, then what about this one? Which one is minimal? Even this is minimal, na? Here gamma 3 is extra attribute, so that is not possible. This type of set, if you are saying that it is a set of keys, then it's not possible. Are you getting my point?
No, sir. No, it's not getting. Repeat it, sir.
Okay, suppose that I'm saying that my keys are like this: SID. One is SID and S name. I have two keys. Is it possible?
No, no.
Yeah, that's the same case, na? When you are saying that SID, when you are saying that SID S name, but when you are saying that SID S name and S branch, this is not possible, na?
Yes, sir.
That's why. Okay. Next is
Sir, a doubt is there. But it is not possible. But how multiple candidates key can be found in a single table?
okay. Suppose that you have a relation R with some attribute. I am just make it simple. You have the attribute A, B, C, D, E. Suppose that A is SID, B is S name, right? Now my key may be like this. One is A, one is BC, one is DE, CDE. Yes or no? Because only C is not a key. But if you make the B with C or C with DE, it give you the unique answers. Yes or no?
Yes, yes, it will be.
Are you getting my point? That's why
Okay.
now this type of set is possible. But now see, is it possible? One is A, one is AB. No, it's not possible because AB is now not minimal one.
Sir, it is okay. Sir, a little bit go upper. A little bit go upper that alpha, gamma, that question. Sir, that means that alpha, beta one is in and second, third, and fourth person also, sir.
No, 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 no. Only second and fourth will create a problem. Only fourth create a problem for second one because
But
here
beta one is in three places
no.
also. Beta one is there now.
See. Only beta one itself is not a key.
Okay. Got it.
Then when one key is part of another key, it means it is not the minimal one.
Okay. Got it.
Are you getting my point?
Got it.
So these are very simple, tricky questions. If you bit comfortable, then hardly it will take 10 seconds to give you the answer. Okay. Okay, great. So let's talk about one of the terminology that is called prime attribute. Can you just tell me what's the prime attribute? Any idea?
Sir, they are
See,
attributes which are part of the candidate key.
yeah, very good, very good. It's the attribute which are part of candidate key. Attribute belongs to, I can say, or part of candidate key. Like, suppose that I have a relation R with A, B, C, D, E, F. Okay, these are the attributes of my table. Now, my candidate key set is like one is A, one is BC, one is D. So, can you just tell me what are the prime attributes? Can I say A is a prime attribute? Yes or no?
Yes, sir.
Can I say B is a prime attribute? Is B is a key?
Of course.
B is
Yes,
not
sir.
a key. Key is my BC, but B is part of that key. That's why it's prime. Are you getting my point? Prime attribute doesn't mean that attribute is a key, but that attribute is a part of any key. Are you getting my point? Can you just tell me C is a prime attribute or not?
Yes, sir.
C itself is not a key, but yeah, C is the part of a key. Which key? BC key. Can I say D is prime attribute?
Yes, sir.
What about E?
No.
That's why it is called non-prime. So E and F are non-prime attribute. Are you getting my point?
Yes, sir.
Now we already discussed about what is candidate key, what is primary key, what is prime attribute, what is non-prime attribute. We already covered. Now can you just tell me what is simple key? What is simple key? Simple means a key with single attribute. Fine. And what is compound key? That is key with more than one attribute. Okay. Example. So this is your key set. Now this one is my simple key and this one is my compound key. Are you a bit comfortable? What do you mean by simple and compound key?
Yes, sir.
Okay. The next terminology is super key. Can you just tell me what is super key? See, my dear son, super key means it's first of all it has to be candidate key. Plus, with that candidate key, you can add any number of other attribute, any number of attribute. Any number means zero or more attribute. Now, listen carefully. This is very important. Now, see, suppose that your key set is like this. So first of all, your relation is A, B, C, D, and E. And your key set is A and B, C. Now, can you just tell me, we have need to identify the super key. Is A is a super key?
Yes, sir.
A is a super key, okay? Is B is a super key?
No, sir.
No.
Is BC is a super key?
Yes,
Yes,
sir.
sir.
Okay, what about ABC?
No.
Yes.
Yes, because it's a candidate key plus zero or more attribute. Yes or no? That's why it's a super key. Can you just tell me D is a super key?
No.
Why? Because it is not a key, candidate key even though. Can I say uh, can I say CD?
No.
Why?
It's not a candidate key.
Very good. Neither C is candidate key, neither D is candidate key, neither CD is a key. Are you getting my point? But now BCD. Can you just tell me it's a super key?
Yes.
Very good, my dear. Is there any confusion in the super key? Super key just means candidate key plus some extra attribute. Extra may be anything. It's zero or more than zero. Can I say A, B, C, D is a super key?
Yes, sir.
Very good. Now, my next task is to find number of super key. Now, suppose that, my dear students, I have a relation with A, B, and C, where I can say my candidate key is A, only A. Can you just tell me total number of super key possible? Please identify. What is the total number of super key possible in this case?
3.
4.
No.
Sir, 4,
4.
including A, 4.
Very good. 4 is the right answer. One is A, one is AB, one is AC, one is A, B, and C. Are you getting my point?
Sir, will A will be included?
Yeah, because the answer is candidate key plus zero or more attribute.
Okay, okay. Got it.
See here in this case. Yes or no?
Okay, sir.
Now, so in the general case, if I can say I have a relation R with alpha 1, alpha 2, alpha 3, and alpha n attributes. And when my candidate key is only one candidate key with single attribute, then the total number of super key possible is how many? What is the formula?
So is it 2 power n?
It's 2 power n or 2 power n minus 1?
2 power n minus 1.
2 power n, 2 power of n minus 1.
N minus 1. Why n minus 1? See, if I am just writing 2 power n, what does it mean? It means we have n attribute and each attribute having two choices. But right now, because my key is A and A is part of each and every super key, it has to be there. It means there is no choice for A. So how many number of attribute having the choices? N minus 1 attribute and each attribute from n minus 1 having two choices. That's why 2 to power n minus 1. Are you getting my point? That's why in this case total number of super key possible is 2 power of n minus 1. Are you getting my point?
Yes, sir.
Very good. Next time, next again, suppose that you have a relation R with A, B, C, and D. And now in this time you have two candidate key. One is A and one is B. Can you just tell me number of super key?
Eight.
Okay. What are those? If you are saying that it's 8, what are those? Can I say A? Next one.
AB,
AB. Okay.
AC, AD,
AC.
ABCD,
Wait a second. AD. Next one.
ABCD,
ABCD. Okay. Next one.
B, BC,
Okay. You can just you over with the A.
ABC,
ABC. Okay. Next one.
ABD,
ABD. Yes. Right. Very.
yes, ACD.
ACD. I think already covered. No.
No, no.
ACD.
Then B.
Only D.
B. Next A
Only
over.
B. Okay. Then
BCD,
next
BAD,
B.
AD,
ABD. I think we already covered ADB.
yeah,
It's already more than 8. So can you just tell me what's the total number of keys possible, or total number of super key possible in this case?
yes, 10.
Just try. Try, please. You can just write down like manually all the cases, then you will get to know what's the answer. Just try for the simple answer.
Sir,
When we have a relation with the 4 attribute, where 2 attribute individually having the key. So can you just tell me total number of super key possible in this relation?
is it 12?
You are saying that it's 12. So right now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you give me 2 more?
Sir, BD?
You are talking about PD. Absolutely true.
And then ACD, sir.
BC also.
Sir, BC.
AC is already there.
Sir, BC.
BC, very good. These are the 12. So I can just delete this one or mark it as wrong. Fine, so these are the 12 cases. So now, my dear students, very simple. Can you just tell me with the help of A, how many super key possible? Can I say 2 power of 4 minus 1? Yes or no?
Yes, sir.
With the help of B, again we have 2 power of 4 minus 1. Yes or no?
Yes, sir.
But now problem is, in case of A, whenever I am writing the all the 2 power 4 minus is 4 minus 1 is 8. So because 4 minus 1, 3, 2 power 3 is 8. I am just writing AB. I am just writing ABC. I am just writing ABD. I am just writing ABCD. And while I'm writing the set for B also, I'm writing AB, I'm writing ABC, I'm writing ABD, I'm writing ABCD. So I'm counting 2 times, yes or no? It means whenever we have a key, super key, which contains both A and B, that counted twice. Now we have to subtract that part. It means 4 minus 2. Here minus 2 means AB. Are you getting my point? So now my answer is 8 plus 8 minus 4, which is 16 minus 4 is 12, and these are the 12 one. Are you getting my point?
सर ये लास्ट वाला समझ नहीं आया जो आपने 2 की पावर 4
लास्ट वाला मैंने ये बोला कि जैसे जैसे उस सुपर की में जिसमें दोनों ए बी आ रहे हैं, वो ए वाले पार्ट में भी काउंट हो गया, बी वाले पार्ट में भी काउंट हो गया। तो हमें एक बार माइनस करना पड़ेगा ना, हमने उन चीजों को 2 बार काउंट कर लिया, जैसे ए बी यहाँ पे भी आ गया, यहाँ पे भी आ गया, ए बी सी यहाँ पे भी है, यहाँ पे भी है, आपने दोनों सेट में काउंट कर लिया ना।
बट सर अगर बी में ऐसे हो बी ए या फिर बी ए सी, तो वो सेम
हाँ
ही चीज है ना?
हाँ, देखो बी ए सी, बेटर वर्ड है कि इसको मैं ए बी सी बोल दूं,
यस सर।
और इस केस में भी वो आ सकता है, ए बी सी आएगा ही आएगा।
हाँ।
ए वाले केस में भी वो की सुपर की बन जाएगा, बी वाले केस के लिए भी वो सुपर की बन जाएगा। आपने तो 2 बार लिख दिया ना इसे, तो एक बार तो माइनस करना पड़ेगा, और वो कौन सी चीज माइनस कर रहे हो? सो जिसमें ए बी आ ही रहा है, वो सुपर की जिसमें ए बी आ रहा है, वो ए में भी आ गया, वो बी में भी आ गया, दैट्स व्हाई आई एम जस्ट सबट्रैक्टिंग इट with one time. Okay, so the general case is, suppose that you have a relation R with attribute a1, a2 up to an. In that case, suppose that your candidate key is a1 and a2. So the total number of super key possible is, with a1 you can write to power n minus 1, with a2 you can write total number of super keys, but now n minus 2 is there, it's n minus 1. So these many number of super key possible. Y2, 2 is for A1 and A2 combiningly. Y1, this is for A2. Y1, this is for A1. Are you getting my point, everyone?
Yes, sir.
Now, can you just tell me in this case, suppose that you have a relation, and now the candidate key are like this. One is A and one is BC. Can you just tell me its total number of super key? Just try it manually first, then we'll make a formula.
The 8 super keys.
You are saying 8? Can you just tell me, can you give me the name of all these 8 super key?
Sir, A,
A is the right answer.
AB,
AB is the one.
AC,
Okay.
AD,
Okay.
ABC,
Mm-hmm.
ABCD,
Pardon?
ABCD, BC,
BC. Okay.
BCD.
Other than that,
ACD.
ACD. Uh, yeah. Okay.
ABD.
I think already ABD is there. No.
No.
Yes, ABD is also possible. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So can you just tell me? Okay. Okay. You can try first. With the help of A, how many super key possible? Can I say 2 power of 4 minus 1? With the help of BC, how many super key possible? Can I say it's 2 power 4 minus 2? And when both are combining, like A, B, and C, you have to subtract like 2 of 4 minus 3. Yes or no?
Yes, sir.
So it's 2 power 2 power 3, that is 8. Are you getting my point? Why I'm writing like this? Is there anyone having any doubt? And these 10 are the answer. Yes. Anyone having any doubt?
No.
Now, can you just tell me? Now we have the candidate key like this. One is A, one is AB. Can you tell me total number of super key? With the help of A, how many super key possible? Can I say it's 2 to the power 5 minus 1? With the help of AB, how many super key possible? Can I say it's 2 power of 5 to the power 5 minus 2? Yes or no?
Yes, sir.
No. How is it possible? Can I say it's AB is candidate key possible? No, na?
No.
When A is already there. Are you getting my point?
Yes, sir.
Now can you just tell me how many super key possible? Try it once. How many super key possible?
Is it 6, sir?
6, okay.
7, sir.
7, okay.
7.
7, okay. So now can you just tell me with the help of AB, how many super key possible?
Mm.
With the help of AB, the total number of super key possible is 204 minus 2. With the help of AC, how many super key possible? 204 minus 2. Yes or no?
Yes, sir.
But now wherever A, B, C is there, because it is a set of attributes, so I cannot like write like A B A C. A B A C means ABC only. Okay, that means can I say it's 4 minus 3? Yes or no?
Yes, sir.
So it's 7 is the right answer. Any doubt?
No, sir.
Okay. Now, I have a relation R. Can you just tell me how many minimum super key possible? And next question is how many maximum super key possible with n attribute relation?
So candidate key.
No, I'm talking about that. That's why I'm talking about the minimum and maximum. Now, if I just give you the candidate key, then the answer is fixed one. There is no case of minimum and maximum.
Okay.
Just try, just take a simple example and then you will get to know what is the minimum and the maximum one. Just take a simple example of 3 or 4 attribute.
So minimum is it 1?
Minimum is 1. Why? Can you give me the answer?
Sir, if we have candidate key as the collection of all the
No, your voice is breaking, I think.
attributes
Sorry
in
for that,
the
your voice is
first
breaking. Anyone who can try? Yeah. Thank you so much, but your voice is breaking. That's why I'm unable to understand what you are
if we
saying.
have the candidate key as the set of have only, so when there is only one candidate key,
Yeah, you are right. Your answer is right. Suppose that you have a candidate key, only one candidate key, but that candidate key is consists all the attribute. Then we have only one super key possible. That is the candidate key itself. Yes or no? Then how many minimum super key possible? One. What about the maximum super key?
Sir, is it 2 power n minus 1?
2 power n minus 1?
It's n.
No.
Or like if you multiply like for each n, like n into 2 power n minus 1.
So the answer is 2 power n whole minus 1. And when is it possible? It is possible when all individual single attribute is a candidate key. Like A1 is a candidate key, A2 is a candidate key, AN is a itself is a candidate key. In that case, now suppose that my dear students, I have a relation R with A, B, C. And suppose that the candidate key are A itself, B itself, C itself. Then what is the super key? Now see. According to my case, it's 2 power n minus 1, which is 2 power 3 minus 1, which is 7. So can you just tell me with the three element how many subset possible? 8. And what are these subset? One is empty set, then one is A, one is B, one is C, one is AB, AC, BC, and ABC. So again, that's why if we ignore the empty one, all the remaining subset is considered as a super key, like A, B, C, AB, AC, BC, and the next one is ABC. Yes or no? That's why it's minus 1. It's minus 1 for empty relation or empty subset. And 2 power 3 is total number of subset. Are you getting my point? That's why maximum number of subset possible is yes or no?
Yes, sir.
Fine. So these are some of the questions related to super key. You may find one simple numerical type questions. And it's very hard to like get the numerical type questions in this exam, but still you have to be ready with some of the simple problem set. So we already discussed about super key, alternate key, primary key, non-prime attribute, prime attribute, compound key, simple key, candidate key, primary key. Okay, fine. Now I'm writing two statement. Can you just tell me which one is true or false? The first one is every candidate key is super key, and the second one is every super key is candidate key. Which one is true?
Second one is true.
Candidate key is super key.
Every candidate key is super key. Can I say every super key is candidate key?
No,
Why?
because the extra attributes may not be present as candidate key.
Very good. That's why first one is true and the second one is false because super key need not be minimal. That's why suppose that A is candidate key, B is candidate key, AB is also AB is super key but not candidate key. Suppose that it's a candidate key, but now this is not possible. But now it's a super key, it's a super key, it's a super key because there is no constraints of minimal type thing in super key. Okay, that's why every candidate key is super key, but every super key need not be a candidate key. Are you getting my point?
Yes, sir.
No, fine. Now one of the important topic is like the concept of abstractions. In database management system, or the database management system provide you three level of abstractions. What is that? Suppose that you are the user. So the three level of abstraction is first one is external schema. The next one is conceptual schema. We can call it as logical level also. Third one is physical schema. We can call it as low level schema. And the next one is DB. So we have the abstractions in this way. Fine. So this part we can call it as DBMS. What is the functionality of this one? We will see. So if I talk about the logical level, it tells you what data exists in DB. And the physical schema or the low level design tells you how data physically stored. Or we can also call it as metadata. What do you mean by metadata? It's data about data. Fine. That's why if I talk about the physical schema, or we can also call it as low level or internal level, so it gives you the complete detail of data storage. That means how physically data is stored and the access path for the DB. That means like what's the file name, what is the location of that file, what's the type, what is the accessing way. It's the simple direct way or it is using indexing. Whereas if I talk about the conceptual schema, it hides the physical detail. It not bother about how data is stored, but it tells you what data is stored. Fine. It only describes the structure of the whole database. Like it gives you the abstraction, like suppose that we have a table called student, then it only tells you my student table contain SID, S name, date of birth, and the branch, suppose. But it never tell you what are the exact data is. That's why it is called conceptual schema, logical view, not the exact or the physical view. And if I talk about the external schema, basically it is used to provide the different level of security. Suppose that you are the student of university, so you can access the database with some constraints, like you can see your roll number, you can see your marks, but you cannot see the marks of other students. Whereas as a faculty, I am the another schema, or I have some extra level of security, means I have some extra level of permission also, means I can see the marks of each and every student, but student can't see my salary. Fine. That's why external schema is used to provide the extra level of security. Are you getting my point? So these are the level of abstractions you need to keep in mind. What is the main functionality of conceptual schema? It tells you exactly what data is exist in the DB, how it is stored. It not more about that. But in the case of physical schema, it's bother about that how data is actually physically stored in my DB. That's the level of abstraction. So always keep in mind in database management system, it gives us the three level of abstraction: concept, external schema, conceptual schema, and physical schema. Fine. So that's all about today's lecture. Tomorrow we are going to discuss some of the important concept. So today we just cover the different terminology. What's the database? What is database management system? Then what is key, what is the use of key, what is candidate key, super key, primary key, prime attribute, non-prime attribute, simple key, compound key, alternate key, and super key. Then also we find how to find out the total number of super key, and then the last topic is what is abstractions, or what type of abstractions provided by database management system. It gives us three level of abstractions: external, conceptual, and physical. So we will meet again tomorrow at the same time at 9. So I'll share this PDF with you. Maybe I'll provide you to the in the executives, and you'll see will upload on the on the panel, and you can access from there. Okay.
Excuse me, sir.
Yes.
Sir, can you please tell like the brief syllabus of like DBMS, like what we have to cover for this exam?
Like mainly we are going to cover the basic things like this, and then the normalization, and then the ER is one of the important, not in that much detail, but simple ER, and then the SQL. Then what is DDL, DML, DCL, DTL, basic things. Okay.
Okay, sir.
Yeah.
Thank you, sir.
Is
Thank
normalization
you.
also there, sir?
Pardon?
Normalization.
Yeah, normalization is like we just go with the 1NF, 2NF, 3NF, BCNF, but how to convert it, that's not the part of our syllabus. Just what is 1NF, the basic definitions. Okay. What the normalization is, what is lossless, what is dependency preserve, what are 1, 2, 3, and BCN. Okay, my dear students, thank you. Any other doubt?
Okay, sir. Thank you.
Okay, thank you. Thank you so much. Have a nice day.